Welcome to a new test and teardown video. Today we're going to play with an XY plotter from Lloyd Instruments. It's called type PL100. And as you see here, we got analog XY inputs. And we can do sensitivity, damping, zero, and we of course got the two analog channels inputs. We got some really funny things about the about the knobs here. Look at that. You need to pull them and then pull to unlock. That is cute. But why? I think it is in a quite beautiful cosmetic state. I also feel that like this is, there's a little bit of a tight feel here around the middle. I just put a piece of paper in it and there was a little magnetic rubber stripe here. I guess this is just to hold the paper. We got standby, XY mode, or time, maybe. But how do you set the time? That I don't know yet. We also got XY mode or dynamometer mode. And I believe this is for the dynamometer sensor. So if you put in that sensor and go into dynamometer mode, you'll be able to make a graph of some sort of a motor, its power output versus RPMs and stuff like that, depending on how the sensor works for this particular instrument. But I don't have the sensor, so I need to play with this in XY mode. I just wanted to show you guys that was what it's all about. And of course we got the mains on off. So let's go to standby mode and let's try and power it up. So first we just plug in mains here. There's no power consumption. Oops. That was interesting. We are in standby mode. So why are you moving? So here is, oi. Yeah, that is what I said. Can you hear that? So up here, it's good. Okay, there's definitely what I said about some kind of a weirdo feeling here. And then, oops. That is probably the standby, right? So let's go to XY. Whoa. So that was damping. Okay, it is responding to zero. Yeah, okay. Whoa. Sensitivity is crazy. Let's turn this down. What are we doing wrong here? It's absolutely crazy. But it seems to be working. Ha. I got two sine waves running right now. And what you can see is that we have a little bit of mechanical hysteresis. So I need to take it a little bit apart and lubricate and make everything move a little bit more nice, especially the x-axis here. As you can see, it's very, very jumpy, maybe a little bit too sticky. something like that maybe. So that'll be my next move. I just feel a need to share my frustration. So that will be the end side panel thingy. And by the way, look, they're completely symmetric. So what goes up also goes down. So I think this is exactly the same for both of the sides, right? Anyway, we got those metal sticks and they go through, all the way through into the other side, right? And then you got these little finger nuts. And of course, when you take out the first set, then they just spin around when you try to unscrew in the other end. And now the unit can't stand on the table because it's now standing on the back side. And this piece of metal here is one piece that go around like this. So now comes the funny. How do you disassemble this? This is not easy. Okay, so that was easy. Okay, so I could take the other side out, including the long stickety sticks, and then put this on the floor. Remember, this unit is 63 centimeters wide, 42 centimeters steep, and 18 centimeters high. So as you can see here, there's a lot of space. I just need a lot of space, right? So yeah, wires in here, and then I should be able to pull it out, and then we can continue. So here's how it works. This is the x-axis, and we got a slider down here that is creating a contact to this wire. So this is a resistor wire, and this is the position of X. So it's a linear potentiometer, actually, right? And then there's a magnet here, and we got two end switches. This one is tick. This one is even working. How can that work when the magnet is all the way down here? It's really a weak magnet. So I would probably have put the magnet here, right? So it could work. And the other one is, of course, not working. Look at that. It's all the way up there and the magnet is down here. So if I move this all the way to the end, I don't hear any clicks. And I also see this slider goes up over the soldering and damaging the slider. So that is, of course, not good. So either I need to move this contact down. That's probably what I want, because I don't want the x-axis to go all the way in here and create. Yeah, I need to move the stop. Or I could add another magnet up here. Probably that is how it should have been. This is not so good. And I also see some adjustments. I need to make some adjustments here. But look at how slippity-slappity designed this is. This thin, flimsy metal here is just bendy, and everything is so thin. Oh, by the way, the y-axis is made a little bit like the same. You can see the slider down there. So if you look right there, right? So that is the slider, and then there's a similar resistor underneath. It's on the back. Okay, look at that. By adding a little mirror, I can now show you that contact. Haha, that is funny, isn't it? Now we can see what's going on underneath the y-axis. That's a good idea with the mirror, huh? So here's the back side. We got two motor driver circuit boards, and they are more or less the same, just a little different color. It's a two-layer design. We got two big power transistors. That is definitely for driving the motor And we got some op amps and such. Quite normal. There's a socket, so you could pull out the board if you want to service it. And one of them looks like some corrosion, so maybe somebody dropped some nasty liquid. So I also need to clean that. And yeah, I will probably try and see if I can get this board out. I'm a little bit afraid of how difficult is it to put back the screws. But that I want to clean. And I also want to try and clean the contact wire and maybe lubricate anything that moves. So I hopefully I can get it to a nice smooth move. So this is behind XY analog inputs. I see two circuit boards. They are behind a front panel lid here. I think we can maybe take this plate away. Yes, you could do that from the front, and then you will access those two circuit boards here, and they consist of some resistors, probably for input attenuation or input range setting. So maybe you can make this more sensitive or less sensitive, depending on your needs. I see only a few, three resistors like that. So that's all there is to it, really. So here's what I've done. I cleaned the resistor wire and I desoldered it and then pulled it so it's nice and tight, because it was a little bit loose before. Also the slider springy has been cleaned. All bearings got a tiny little drop of lubricant. This one is cleaned. I also opened this to access the bearings in here, and then I carefully moved each of the stops so now they work when the sled go down there. And we got more bearings, all 4 of these, and here is the controller board. That will be a fuse. So each, the positive and the negative supply to the motor drive, got a tiny little fuse wire and some op amps. And I see 1977. I'm having a hard time getting the pen to touch the paper, but I think you get the idea. I'm running some sine waves here, and then it gets stuck over here. Oh yeah, you see, because the plate here is not completely straight. But anyway, see, just push it down like that. But anyway, I think I got it more or less up and running. I just need a little springy sort of holder here for the pen, and then it could definitely work. And yeah, you see. Anyway, that is a lot of fun. Thank you very much for watching. Bye bye.